Hello everybody, welcome to my channel AKB Tutorials. So in this channel we are discussing various topics related to mechanical engineering. Today we are going to learn one of the most important topics of strength of material, that is Mohr Circle. So what is actually Mohr Circle? So it is the graphical representation of two-dimensional stress system on a sheet of paper. So we have seen the analytical methods by which we can determine the stresses developed on an inclined plane. Consider the most complicated case, that is of two-dimensional stress system, that is the body is under sigma x stress along x direction and sigma y stress along y direction, and the tau xy, that is shear stress acting on face x face in anti-clockwise sense, and on y face the stress is acting in clockwise sense, that is tau xy. So shear stress and complementary shear stress value will be same. So that we have seen. So on this inclined plane, which is making at an angle theta with positive x direction, there are two stresses developed, sigma n and tau. So we have got the formula for sigma n and tau. So we have seen in the last analysis, that is sigma n is given by, for this system of stresses acting on the element, that is sigma n is equal to sigma x plus sigma y by 2 plus sigma y minus sigma x divided by 2 cos 2 theta minus tau xy sin 2 theta, and we have got tau value as sigma y minus sigma x by 2 sin 2 theta plus tau xy cos 2 theta. So we have got these two values of sigma and tau, which is developed on the inclined plane. The inclined plane makes an angle theta with x axis in anti-clockwise sense. So that means when we measure the angle from positive x direction, this is the x direction, from positive x direction if we measure the angle, this angle becomes theta. So we have got these two formula from analytical method. So if we put the values of sigma x, sigma y and tau xy in these equations as well as theta, so we will get sigma n and tau value. But we can analyze, means we can get this value, that is sigma n and tau, by using Mohr circle. How? That is a graphical method. It is given by Mohr, so that's why it is called Mohr circle, and we are going to see the basics of Mohr circle. Why it is, how it is given by Mohr circle. So we have got the sigma n and tau value. So For time being, we are considering sigma n minus sigma x plus sigma y by 2. It gives sigma y minus sigma x by 2 cos 2 theta minus tau xy sin 2 theta. So this was the first equation. So if we square this equation, then this will be like this. Okay. Similarly, if we square that tau equation, so it will be sigma y minus sigma x by 2 cos 2 theta, sin 2 theta plus tau xy sin 2 theta whole square. Now if we add these two equations, so sigma n minus sigma x plus sigma y by 2 whole square plus tau square. So we can write sigma n minus sigma x plus sigma y by 2 whole square plus tau square. Let's see what happens. So squaring two equations and adding, then the right hand side becomes sigma y minus sigma x by 2 whole square cos square 2 theta. So we can write sigma y minus sigma x by 2 whole square cos square 2 theta plus 2 into this value, that is sigma y minus sigma x by 2 into cos 2 theta into tau xy sin 2 theta plus tau xy square sin square 2 theta, then this value plus sigma y minus sigma x by 2 whole square sin square 2 theta plus, so this becomes minus, this becomes minus and this becomes plus 2 into sigma y minus sigma x by 2 sin 2 theta into tau xy sin 2 theta, this is cos 2 theta, So 2 sigma y minus sigma x by 2 sin 2 theta into tau xy cos 2 theta plus tau square xy cos square 2 theta. Okay, so then this and this will cancel out because plus minus, and ultimately it will give sigma y minus sigma x by 2 whole square, sigma y minus sigma x by 2 whole square. If we take common cos square theta plus sin square theta, so it will be ultimately sigma y minus sigma x by 2 whole square plus sin square theta into sin square theta plus cos square theta, that will become 1. Similarly, if we take common this one and this one, tau square xy, it will be common plus tau square xy. Okay, so that means this value becomes this, where theta is not available. In this equation, the theta is not available. If we square the two equations and add it, there is no theta value. So ultimately what we are getting, I am writing here, that is sigma n minus sigma x plus sigma y by 2 whole square plus tau square, okay, that is equal to sigma y minus sigma x by 2 whole square plus tau xy whole square. So this is the equation. When we add these two equations, we get this. Now you can see this is the equation of a circle, because, or we can write sigma n, and this is a constant value, so we can write sigma n minus a whole square plus say tau minus 0 whole square is equal to square root of sigma y minus sigma x by 2 whole square plus tau xy whole square. So we have got this equation. Now this is the same equation as capital X minus a whole square plus tau minus 0, sorry, y minus 0 whole square is equal to r square. So this is the equation of a circle where the center of the circle is given by a0, center of the circle is given by a0. So in equation of circle we have got center of circle is equal to a0. So that will be equal to sigma x plus sigma y by 2 comma 0. This is the center of Mohr circle, and radius of Mohr circle, it is given by square root of sigma y minus sigma x by 2 whole square plus tau xy whole square. So this is the equation of a circle. So that means the two equations what we have got, that is sigma n and tau on inclined plane. If we add these two equations by squaring and adding, so sigma n minus sigma x plus sigma y by 2 whole square plus tau square is equal to this, means this is the equation whole square. So this value is r is given by this. So that means we can express, by combining these two equations, we can express in the form of a circle. That's why it is called Mohr circle. Now we'll see how to draw the Mohr circle. First we'll see, we'll take case, the same case we'll take, and we'll see how to draw the Mohr circle. That is most important. So you should understand the steps how to draw Mohr circle. This is the stressed body. The body is under sigma x stress, that is tensile acting along x direction, sigma y stress acting y direction, that is also taken as tensile. Then tau xy, which is acting on x phase, we are considering it is in anti-clockwise sense, and tau xy, which is acting on y phase, that is in clockwise sense. The same case we have considered here, that is tau xy, and also the plane, inclined location of inclined plane, it is at an angle theta from x axis in positive direction, and sigma n and tau value and sigma n value we have to find out by using Mohr circle. By using Mohr circle, we are going to find out sigma n and tau value. So, to construct this Mohr circle, first we have to draw the axis. Step 1, we have to draw the axis. So, this is the tau axis and this is the sigma axis. So, draw two axes perpendicular to each other, that is sigma axis and this is the tau axis. So, this side also. So, this is the origin. Origin is at O. So, we have drawn sigma axis, tau axis perpendicular to each other. Now, go to x face. Before that, we will see the sign convention. So, this is most important, sign convention. If sigma x or sigma y is tensile, then we will take as positive stress. If sigma x and sigma y is negative or compressive, so we will take as negative stress. And regarding the shear stress, if stress is acting in anti-clockwise sense, so we take it positive. So, anti-clockwise shear stress, is taken as positive. So clockwise shear stress will be is equal to negative. So these are the sign conventions, sigma x, sigma y and tau xy. Okay, now we have drawn the axis, that is the step 1. By following this sign convention, go to x face. This is the x face on which the plane on which x direction is perpendicular. See the condition of stresses. So sigma x and tau xy is acting on x face. We are giving some numerical value. Sigma x is equal to 50 megapascal and say tau xy it is 20 megapascal. So some value will be given, and sigma y we are considering say 30 megapascal. So go to x face and see what are the stresses acting on x face. On x face, sigma x is 50 and tau is 20. Both are positive. So from origin measure a distance by using some suitable scale. Say this one is 50 and positive. So this is positive sigma direction, and this is the negative sigma direction, positive tau direction, negative tau direction. So we have plotted the same graph in the 10th syllabus, that is xy graph. So similarly here we will use sigma tau graph. So first point, you just plot by measuring sigma is equal to sigma x is equal to 50, tau is equal to 20, both are positive. So 50 and 20, say this point is coming. So this is the point 1 and we are giving 50, 20. Now go to y face. Y face, which face is y face? The face on which y axis is perpendicular. So this is the face. So on y face, what are the stresses acting? Stresses sigma y is positive, but tau xy it is in clockwise sense, so it is negative. So 50 that is 30 positive and 20 negative. So by using the same scale, say this one is 30 and say 30 is coming here. 30 is coming here, then 20 negative, so 20 you will get here. So we are getting point 2, that is 30, 20. So we have got 2 points, that is the first point and second point. Then join these 2 points by using a scale. Just join these 2 points. It will intersect somewhere with sigma axis. So this is the center of Mohr circle. Okay. So this one, take this one as center, and this distance as radius, draw the circle. So if we draw the circle, we will get this circle, and this circle is called the Mohr circle. This circle is known as Mohr circle. So we have drawn the Mohr circle by the information given on the stressed body. So we have drawn the Mohr circle where center and this is the radius. Radius means C21 or C2.2, that is Mohr circle. So first step we have drawn the axis. Second step we have drawn the circle. Third, we will find the x direction. So to find the x direction, so this is the sigma direction. Where is the x direction? So in this we will find where x phase point is plotted. X phase, the stress system on x phase, it is plus 50 plus 20. So this point is the x phase point. So center to this direction is called x direction. X direction. So we have got x direction, and center to this direction, this is the y direction. Center to this direction, C to 2, extend this is y direction. So we have got, we don't require this, we require x direction. We have got x direction. Now in the stressed body, just locate the plane. Plane is at an angle theta from x-axis in anti-clockwise sense. So here we will rotate this x direction by 2 theta angle in the same sense. So if we rotate this x direction from here, you measure 2 theta angle and rotate this x direction. So here we are writing, here I am writing 2 theta angle. So rotate x direction by 2 theta angle in the same sense. Here it is anti-clockwise sense, so here we will rotate in anti-clockwise sense by 2 theta angle. Okay, and this direction is, I am giving the name, that is new x direction. So what is new x direction? Now x direction after rotation is termed as new x direction. Now extend this new x direction so that it will intersect at some point on opposite side of the circle, and this point is called foot of new x direction. Foot of new x direction. This is the foot of new x direction. So foot of new x direction we have got and marked by point P. From point P, drop a perpendicular to sigma axis, and we are giving the name Q. So this angle will be 90 degree. Now the problem is solved. By measuring, we have to give the answer. Measure the distance from O to Q, that is this distance, OQ distance. So from here to here, measure the distance. So this distance will be your sigma n distance. So sigma n, that is sigma n, this value sigma n on inclined plane is given by distance, that is OQ, that is from origin 2q point distance, just measure by using that same scale. So you will get, that is sigma n value on the inclined plane. So as this sigma n value is towards the right, it will be a positive one. Positive stress means tensile stress. Now, if we measure the distance PQ, so that will be your tau value, that is PQ. So you can see it is below, that means it is negative, and that means this is a clockwise stress. Clockwise stress. So we have got sigma n value, we have got tau value. Now join O to P. This distance O to P. So O to P, this distance will give you sigma r value, that is resultant stress on inclined plane, and analytically it will be root over of sigma n square plus tau square. So sigma n and tau are the stresses on the inclined plane. So what will be the resultant stress? Root over of sigma n square plus tau square. So that is given by distance OP. Measure this angle. Let this angle becomes phi. So what is phi? By measuring. So this angle is called angle of obliquity. Angle of obliquity. So again I am coming to the stress. So the stressed body, the various stresses acting on the body is given. So in this case, sigma x is tensile, sigma y is also tensile, and tau xy on x phase is in anticlockwise sense, that is positive, and on y phase tau is in clockwise sense, so that is negative. So now we have to draw the Mohr circle and find the result, that is sigma n and tau value, which is acting on inclined plane. So to do this, first you draw the axis. Step 1, draw the axis. Tau and sigma will be perpendicular to each other. Then plot x phase point. X phase means the x direction is perpendicular on this phase, so this phase is called x phase, and y direction is perpendicular on this phase, so that's why it is called y phase. So x phase point, it is 50, 20, so measure by using a scale 50 and 20 and mark this point 1. Similarly, go to y phase, see the condition of stresses acting on y phase, mark the second point sigma y and tau. So we have got this point 2, 30, 20, this point we have got. Then join point 1 to 2, it will intersect somewhere in sigma axis. Somewhere on sigma axis it will intersect, and that point is called center of Mohr circle. Take this one as center and this one or this one as radius. Draw the circle. So this is the Mohr circle. Now next step, we have to find the x direction. How to find center to the x phase point? So that direction is the x direction. So we have got x direction. Now rotate x direction in the same sense twice the theta angle. So here inclined plane is located at an angle theta from x axis in anti-clockwise sense. So we will rotate x direction in anti-clockwise sense by 2 theta angle. So let this angle, if we rotate twice this angle, so the x direction is shifted here. So we are giving the name new x direction. Then extend this new x direction so that it will intersect at opposite side of the circle. So at point P it is intersecting. So this point P is called foot of new x direction. From this point P, that is foot of new x direction, drop a perpendicular on sigma axis. Okay, then by measuring O to Q, it will give sigma n value. Then P to Q, it will give you tau value. Join OP or measure OP distance, that will give you sigma r value, and measure this angle is called angle of obliquity. What is angle of obliquity? It is the angle made by the resultant stress, with sigma axis. It's called angle of obliquity. So I hope this will clear your idea regarding the construction of Mohr circle. We will solve some problem. So today we will see one problem, and next class we will see some more problems. Okay. Let a body under the stresses as shown in figure. Let this is the stressed body. This body is under various stresses acting, that is sigma x, that is 400 megapascal, that is 400 megapascal along x direction, and it is tensile stress 400 megapascal, and along y direction it is a compressive stress 300 megapascal. So 300 megapascal. And also shear stress is acting on x phase, it is in clockwise sense. Okay, that is 200 megapascal. So 200 megapascal. Now consider a plane which makes an angle theta with x direction in anti-clockwise sense. So this is the problem. Now we have to solve this problem by drawing the Mohr circle. So let us start to draw the Mohr circle. First we have to draw the axis. Say this is tau axis, and this is your sigma axis. So I am marking sigma axis, and this is your tau axis, and this is your origin. Now go to x phase point. What are the stress condition? That is sigma x is 400 megapascal, that is positive tensile stress, and tau is in clockwise sense, that is negative. So 400 is positive. So let by using some scale 100, 200, 300, 400, and tau is negative. So 100, 200. So you will get this point, that is 400, 200. Already negative side we have taken, so no need to write negative 200. So 400, 200. So we have got this point. This point is first point. Now go to y phase. On y phase, shear stress is not shown. Once the shear stress is acting, so complementary shear stress will be there. So we have to consider the complementary shear stress, that is also equal value 200 megapascal. So you can see here 300 megapascal, sigma y value is negative, and this one is shear stress is in anti-clockwise sense, that is positive. So 300 is negative. So from this point you move towards left, 100, 200, 300. So negative point we have got, and 200 is positive. So 100, 200. So we will get the second point, that is 300 comma 200. So we have got, so we have taken directly 300 because we have taken in the negative side only. Okay, so we have got second point. Then join first point and second point by a straight line. So if we join this by a straight line, first point and second point, it will intersect somewhere with the sigma axis, and this point becomes the center of Mohr circle. Okay, so this point becomes the center of Mohr circle. Now consider this one as center of Mohr circle and this one as radius. So complete the circle. So if we draw the Mohr circle, so this circle becomes the Mohr circle. So we have got the Mohr circle. This is the center of Mohr circle, right? Now we have to find the x direction. So this is the center of Mohr circle, and where the x point is plotted, x point we have marked as 1. So this is the x point. So this is the x direction. So this direction is known as x direction, and this direction is known as y direction. So we have got x direction. Now here, where is the inclined plane? So when we will move from x direction in anticlockwise sense by theta angle, we will get the inclined plane. So rotate x direction. So from this point to this point, so we will rotate about this C point by 2 theta angle, 2 theta angle, so that the x direction will be rotated. So this will become new x direction. So we have got new x direction. Extend this new x direction in opposite direction. So it will intersect somewhere in the circle, and that point will mark as point P. This point P is known as foot of new x direction. So we have got foot of new x direction. Now drop a perpendicular from this point to sigma axis. Okay, and mark this point as Q. So this one is your origin. This is the center of Mohr circle, and this point Q we have got, and this is the P point. So measure the distance and give the answer. So measure distance OQ, that will give you sigma n. O to Q, this distance will give you sigma n. So we can write here, this will be your sigma n value. And as it is towards left side of origin, so it will be negative, that means compressive one. The sigma n value will be compressive. And the tau, so measure distance PQ distance, so that will give you tau. Here you can see tau value, it is underneath this axis, so that means it is also negative. Negative means it is in clockwise sense, so trace clockwise. Next, join O to P. So this will be your sigma r. So OP distance, this will be your sigma r, and analytically it is given by root over of sigma n square plus tau square. And measure this angle, that is POQ angle, that is measure POQ angle, that is given by phi, is known as angle of obliquity, angle of obliquity. Okay, I hope this will clear your doubts regarding this Mohr circle. Then also we'll solve some problems in the next video on Mohr circle. Hello friends, so that's all for today's video. If the video is helpful to you, so you will subscribe, share the video. Thanks. Okay, we will meet you soon with the next video.